So we're going to start with 1-3A, which is real numbers. And the number line. Okay, real numbers and the number line. So we'll get into more about the real numbers in just a little bit, but we're going to actually start with square roots. Anyone know what square roots are? Or what symbol goes with a square root? What a square root looks like? Right, you have like a little check mark with a bar over top, right? So that's where we're going to start today. We would say A is the square root of B if A squared equals B. Okay, so A is the square root of B, or we could say, if I turned that into an equation, A is the square root of B, right? If A squared equals B. So these two equations are both true for A and B. It's just a matter of how you're looking at it. Do we want to know what A is? Well, A is the square root of B, or do we want to know what B is? B is A squared, okay? So with that, you have this symbol, okay? The symbol itself, so this little check mark dealie, is called the radical symbol. I grew up in the 80s, so that means more to me than it does to you. Things are radical. Have you ever heard that? Like, that's rad. That's radical. Yes, that's the 80s for you. And then the number that comes underneath it, in this case it's a variable, is called the radicand. Okay, so you have a radical symbol and a radicand. But the whole thing altogether is your radical. Okay, so we're just going to talk a little bit about some square root problems, and then we'll jump into the bigger realm of real numbers. All right, so they're going to tell you to simplify. And to simplify, remember, it just means you're going to break it down as simple as you can, so there is just a number if possible, okay? So if I tell you to simplify these problems, first one, the square root of 81. That means some number times itself equals 81. Anyone know what number times itself is 81? 9, right? So the square root of 81 is 9. Do you know how to put a square root problem into your calculator? Yeah? Okay, for most of you, it's going to be the second key. And then, let me just, well, I can't really do that right now. Why don't you get out your calculator, see if you can find your square root button. If you can't, let me know after I teach the lesson, and I will come show you, okay? But it's a second key, and then that square root for most calculators, okay? So if you want to try plugging that one in just so you get an idea, that would be good. Or you can try plugging this one in. Okay, this one's a little fancy. You have the square root of 25 over 36. Now, if you try to plug that into your calculator, it's probably going to give you a decimal answer. So what I always tell people to do, if you need to plug it in, is plug in the square root of 25, see what you come up with there. Then plug in the square root of 36 and see what you come up with there, and you'll get a new fraction. So your answer is still going to be a fraction. What's the square root of 25? 5, right? 5 times 5 is 25. What's the square root of 36? 6. So your answer is 5 over 6. Okay, so if you see it as a fraction under the radical, just make it two separate radicals. All right. Okay, how about this one? The square root of 64. Do you know the square root of 64? 8. 8 times 8 is 64. Okay, and again, if you don't know them, plug it into your calculator, see what you get. Okay? Yes, ma'am. Yours is right here. So you're going to go second, and then this button. So it creates that, and then you can just do 64 and enter. Okay. All right, last one. What's the square root of 81 over 121? What's the square root of 81? 9. Okay. What's the square root of 121? 11. Okay. And again, I don't expect you to know them off the top of your head. It would be awesome if you did. But if you don't, just plug it into your calculator, or even plug it into your calculator just to double check. Okay? So that would be 9 over 11. So with square roots, we have what are called perfect squares. Do you know what perfect squares are? They're squares that are perfect? Kind of. Perfect squares are numbers that work out to, like, if I take the square root of some number, I get a whole number, okay, instead of a decimal. Like, if I took the square root of 2, I would get 1 point, da, 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 and a really ugly number. But if I took the square root of 4, I get what? 2, right? A nice number, a number that's beautifully ended and doesn't have a decimal behind it, okay? So the perfect squares are those numbers, the ones that look perfect. In other words, 1 squared would be what? 1. So your perfect square is 1, okay? 2 squared is what? 4. So that is another perfect square. What's 3 squared? 9. What's 4 squared? 16. What's 5 squared? 25. What's 6 squared? 36. 6 times 6. What's 7 squared? 49. What's 8 squared? 64. 9 squared? 81. 10 squared? 100. 11 squared? 121. 12 squared? 144. 13 squared? Okay, no, that's good. This is a good place to end. 169, right. Really, if you know through 100, you're in really good shape, right? 1 times 1, 2 times 2, all the way up to 10 times 10. Okay? But these are our perfect squares. You will use these quite a bit in this class. The beauty of it is you don't have to have them memorized. All you have to know is you're doing 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, right? Those are your perfect squares. Okay, because we know those perfect squares, we can then estimate square roots. So that's what we're going to do right now. Example 2, we're going to estimate the square root. Okay, and then we're going to double check it with our calculator just to make sure we're close. What does it mean to estimate? An educated guess, right? Give it like the best approximation you can. Okay, so if I said, what do you think the square root of 34 is? In other words, what whole number is it closest to? Okay. Here's what I want you to do. 6. 6 is great. If you look at your perfect squares, you have 36 and 25. The square root of 34 falls between the square root of 25 and the square root of 36, right? Well, the square root of 25 is 5. The square root of 36 is 6. So this number is somewhere between 5 and 6. Okay, if I plug in, well, before I plug it in, before I show you, based on the numbers we have, 25, 34, and 36, is it going to be closer to 5 or closer to 6, you think?
6.
Closer to 6, because 34 is closer to 36 than it is to 25. Okay, so if I say estimate the square root of 34, I'd say it's about 6. Okay, the squiggles mean approximately. And then you just check it. So let's say I'm going to put my calculator up here to show you. Okay, I check the square root of 34, type it in, and I get that number. Well, if I round that number, I would round it to 6. Okay, let's try another one. Estimate this one. If I give you the square root of 103. Okay, look at your perfect squares. Square root of 103, this was 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, right? Oh, right, you can't see this right now. Here we go. Okay, so if I want the square root of 103, what would you say that's closest to? Don't say it yet. Don't say it yet. Okay, we'll do another one where we don't say it yet. 100, right? The square root of 100 is close to the square root of 103. So the square root of 103 is very close to what whole number? 10, right? Because the square root of 100 is closest to 10. Now, 103 falls between 100 and 121, right? So it's between 10 and 11, but it's going to be closer to 10 because 100 is close to 103. Okay? Okay, we're going to ditch the calculator so I can put the screen back up. All right, how about this one? The square root of 386. Now, for this one, you can't really use the perfect squares list, but what could you do? What? Not add. No. Use your calculator, right? If it's so big that you think, I don't know what perfect square that's close to, plug it into your calculator. So do this for me right now. Plug in the square root of 386. And then tell me what whole number you think it's closest to. Square root of 386. What'd you get, Dustin? Did you plug it in? 19. Anybody else have another idea? 20. Which one is it? It's 20, right? Because you get 19.6. If you got 19.6, that's closer to 20 than it is to 19, right? So this would be approximately 20 if we had to estimate the square root. Does that make sense? Okay, so you are welcome to use your calculator or use the list of perfect squares. I think the list of perfect squares, if you use that, that's going to better your abilities with it. But you are allowed to use your calculator. So, okay, can we move on? All right, here it is. We are going to move into all real numbers. Okay, and in this class, we won't do any numbers that are not real numbers. So everything we talk about in this class are real numbers. There are such things as imaginary numbers. You won't get into them in Algebra 1. You'll get into them in Algebra 2, okay? So for us, everything's going to fall under this big umbrella of real numbers. Under that umbrella, there are going to be two different categories. There are rational numbers and there are irrational numbers. So we're going to start with rational. Okay, so there's rational numbers. that are real numbers. Okay, and rational numbers are numbers that can be written as a fraction. So it can be written as a fraction. In other words, I can write it as A over B. Okay. Along with that, that means it can be a terminating decimal. Does anyone know what a terminating decimal is? Oh, that's a good idea. Terminating, right? Get rid of. It's not getting rid of. A terminating decimal, if you think about like to terminate, that's the end of something. It's a decimal that has an end. So it's not one that keeps going forever and ever. Like, what's the number that keeps going forever and ever? Do you know? Pi, right? 3.1415, da, 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 da. It just keeps going. A terminating decimal is something like 2.75. It has an end. Okay, so a rational number can be the number 2.75 because that can be written as a fraction, right? 2.75 is 2 3/4. Okay, so terminating decimals work. It can also be a repeating decimal. Do you know what a repeating decimal is? It keeps repeating the same thing over and over. So like 2.666666, or you can write it as 2.6 with the bar over top, right? That is a repeating decimal. Again, 2.6 repeating, 0.6 repeating, do you know what fraction that is? 2/3. Yeah. Okay? So if you can write it as a fraction, like a terminating decimal or a repeating decimal, it's considered a rational number. Okay, so those are all rational numbers. Then under that rational umbrella, there are 3 different types of numbers that we're going to talk about. Okay, so under rational, so rational is our A. We're going to do this how we would take notes in English class. Underneath there, there's 3 things, 1, 2, and 3. Number 1, I'm going to move that down a little bit, sorry. Just because I don't want to run into my 2.6 at the end. Number 1 is natural numbers. Okay, and the way I tell people to remember the natural numbers is I say, count for me. Someone count. You started at 1, right? So the natural way to count is starting at 1. So the set of natural numbers is 1, 2, 3, and it just keeps going, okay? And they'll put brackets around the set of numbers. That's why I put the brackets in there. But those are the natural numbers. So think, if I were naturally going to count right now, this is the normal way to count, what would I do? 1, 2, 3, 4, and so on and so forth, okay? The second set of numbers is whole numbers. Does anyone know what the whole numbers are? So they're not going to be decimals. There's no decimal points with whole numbers. There's no fractions with whole numbers. The only difference between the natural numbers and the whole numbers is now we include 1 extra number. Any guess what that extra number is? What? 0. Okay? Is that what you said? Yeah. Thank you, Eliza. Brandon's trying to take your credit. So the whole numbers would look like this. And here's how I tell people to remember this one. You have that O in the middle of the word whole looks an awful lot like a 0, right? So think whole numbers have 0, okay? Third one is the integers. Oops. Does anyone know what an integer is? Includes the negatives, okay? So the integers will go forever off to the left, and then it's -2, -1, 0, 1, 2, and so on and so forth, okay? So that keeps going in both directions, the negatives and the positives and 0, Okay? So basically, every natural number is a whole number and an integer, right? Every whole number is also an integer. So everything below it falls into that category, or everything above it falls into the category below it. It's a weird way to say it. Okay? So integers have negatives. Don't forget those, guys. Whole numbers have 0. Natural numbers, think, how would I naturally count to 10 right now? 1, 2, 3, 4, 5, 6, 7, okay, all the way up, and it has no end. All right, so that's all under rational, okay? Now we're going to do under real. This is going to be your capital B, because it's the counterpart to rational, is the irrational numbers. Okay, and irrational numbers are numbers that can't be written as a fraction. Okay, so I already told you one of these. What's a number that can't be written as a fraction because it goes on forever? No, like the actual number itself that we talked about earlier, that goes on forever and ever and ever. What? A repeating decimal does go on forever. Yes, that's true. It's the other number, the one that makes you hungry for a piece of pie, right? So pi is an irrational number because it's 3.151927, I think. I don't remember how far. But pi is irrational, okay? Another example of an irrational number would be this number, 0.10100010001000, and so on and so forth, okay? There's a pattern to it, but it is not the same thing every time. It's not repeating. The pattern is changing, okay? But you do see there's a pattern there. That's an irrational number, okay? Another irrational number is a number like the square root of 3. If you plug the square root of 3 into your calculator, you get a number that keeps going forever, okay? So that's irrational. Any questions on any of the categories? Okay, so here's the deal. Some square roots are rational and some square roots are irrational. And I just want you to understand that. So we're going to talk about rational versus irrational with square roots. Okay, if I give you the square root of 9, do you think I'm going to put that under the rational category or the irrational category? What? Not irrational. That one's actually rational because the square root of 9 is what? 3, right? That is a rational number. Okay, what if I gave you the square root of 8? Rational or irrational? Irrational. That one does not work out to a nice decimal. So the square root of 8 would go under here. Okay? What about the square root of 49? Is that rational or irrational? That is rational because it's what? 7, right? The square root of 49 is 7. What if I gave you the square root of 21? Rational or irrational?
Irrational.
Irrational. When you plug the square root of 21 into your calculator, you get a decimal that just keeps going. Okay? Any questions on that? So if it comes out to a whole number, like 3 and 7, right? Square root of 9 is 3. The square root of 49 is 7. If it comes out to a whole number, it's rational. If it comes out to a weird decimal that just keeps going, that is irrational. So like, here, let me do this. The square root of 8. Maybe that'll help you see it a little better. This is 2.828427, and it just keeps going, right? The square root of 21 is 4.5825575, and it just keeps going. Okay, whereas these came out to a nice whole number. So those are the rationals. The irrationals are the decimals. Okay? When it comes to square roots, that is. Okay, so I'm going to give you numbers, and you're going to tell me which groups it falls into. Okay, so we had real numbers. Everything's going to fall into real. There's rational and irrational, and then there's natural, whole, and integer. So 5 different groups that it could fall into. Okay? Here it is. This is example 3. Did I give you an example 2? Yes, I did. Okay. Example 3. Name the subsets of real numbers. Okay, so in other words, name the categories these would fall into. So my first number is the number 15. Okay, I want to know what categories 15 falls into. So start at the top. Maybe you're looking at your notes, unless you turned the page. The very first category was rational. Is this a rational number? In other words, could I write it as a fraction?
Yes.
Yeah, how would you write 15 as a fraction?
1 over 15. I mean, 15 over 1.
15 over 1, right? So it's rational. We know that. It falls into the rational category. Okay? Move to the next one. So here's the thing. If it's rational, is it irrational? No, right? It's either rational or irrational. So we know it's rational. So then you look under the rational category. Okay, if you look here, under rational were these 3. So now we're trying to determine, is it natural? Is it whole? Is it an integer? Okay, so is it a natural number? When you count naturally, are you going to get to 15? Yeah, right? So it is a natural number. Is it a whole number? 0, 1, 2, 3, 4. Is it a whole number?
Yes.
Yeah, you're going to get there with whole numbers. Is it an integer?
Yes, it is.
Yes, because integers don't have to be just the negatives, right? Integers are the positives too. So this one has all 4 of those categories, okay? 15 is every one of those 4. All right? Okay, next one. If I give you the number negative 6.375, I want to know which category it falls into. So the first question you should ask, is it rational or irrational?
That's irrational.
Why?
Because it keeps on going.
Does it keep going?
No.
It stops, 0.375, okay? 0.375 you can write as 375 thousandths, right? That's what that is. Okay, so this one is rational because you can write it as a fraction, or you can say it's a terminating decimal, okay? So then under the rational category, is it a natural number? No. Okay. Is it a whole number? No. Is it an integer?
Yes.
No. But everyone, no, listen. This is huge. Everyone makes that mistake with this because people just think integer, negative. But integers are not negatives. Integers are negative whole numbers, right? Not decimals. Thank you, Brandon. So this is not an integer. So this one is only rational, okay? All right, next one. How about the square root of 81? Okay, rational or irrational? Rational, why?
Because it equals 9.
Because it's 9, okay? So this is rational.
Yes, the class.
Okay, is it natural?
Yes.
Yes, because it's equal to 9, right? So, natural, sorry. Is it a whole number?
Yes.
Yes. Is it an integer?
Yes, it is.
Yes, it is, right? Positives and negatives are integers. So it is an integer. The integers are -2, -1, 0, 1, 2, going on and on in both directions, okay? Okay, last one of these. And then I have a pretty picture to draw you if you want it. The square root of 82, rational or irrational? Irrational. If you plug the square root of 82 into your calculator, you get a funky decimal that keeps going. That is irrational. Okay? Questions on that? Okay. If you are a visual person, I'm going to draw you a picture right now that might help you understand these things. Okay? Here's your picture. You have this big box. And in the box are all the real numbers that exist. Okay? That box gets cut into two different smaller boxes. One is the irrational numbers, and one is the rational numbers. Okay? In the irrational category, that's things like pi, or the square root of 10, or 0.101001, so on. Okay? In the rational category are things like -2/3 and 0.3 repeating and the square root of 0.25, okay? But then in that rational category, there are subcategories. So inside rational is integers. And in that integers category, we have things like -4. This one's kind of tricky. -10/5 doesn't look like an integer because it looks like a fraction, right? But -10/5 is -2, okay? Or the negative square root of 16. That's -4, okay? So those are integers. Inside integers, we have the whole numbers, which includes the numbers 0, right? And then within whole numbers, we have the natural numbers, which would be like 6/2, or the square root of 9, or the number 3. Okay, so maybe that helps you just to visualize how they all relate to each other. But basically, if something is a natural number, it's a whole number, an integer, and a rational. Okay? If something is a whole number, it's also an integer and a rational. If something's an integer, it's also rational. Okay? So it kind of works its way outward. Questions on that?